Hello noobs and pros, welcome back to Kubernetes Notes. I am Pani Shidela. Today discussing the important aspect of Kubernetes, which is the master node. I think they renamed master slave naming convention as, parent child, but then when you think about it, parent is doing very little and mostly the actual work is done by the child. Isn't that child labor? Enough about my rant. Let's go back to the episode about the master node in Kubernetes. Kubernetes is nothing but a group of components working together to achieve something. These components can be broken down into two main categories. The first category is the master components and the second category is the node components. Today we'll be discussing the master components, which actually call the shards as to what happens in the cluster. They maintain the state of the cluster. They redirect the client requests to appropriate nodes. The node which runs these master components is obviously called the master node. A master node provides a running environment for the control plane, which is responsible for managing the state of the cluster and is behind all operations inside the cluster. Losing the control plane may introduce downtimes, causing service disruptions to clients with possible loss of business. Therefore, to ensure the control plane's fault tolerance, master node replicas are added to the cluster, and these are configured in high availability mode. While only one of the master node replicas actively manage the cluster, the control plane components stay in sync across all the master node replicas. This type of configuration adds resiliency to the cluster's control plane should the active master node replica fail. Now let's discuss the components of a master node, starting with the API server. All the administrative tasks are coordinated by the Kube API server, a central control plane component running on the master node. This intercepts RESTful calls from users, operators, and external agents, then validates and processes them. During the processing, the API server reads the cluster's current state from etcd, and after the call's execution, the resulting state of the cluster is saved within etcd for persistence. API server is the only master plane component to talk to etcd for both reading and writing data to it. API server is highly customizable and configurable. It also supports the addition of custom API servers. The episode will continue after this short message. If you like our work and would like to support us, you can visit buymeacoffee.com/Chintu. That is buymeacoffee.com/CHINTU. Now, back to the episode. The next master node component is scheduler. The role of a scheduler is to assign new objects such as pods to the nodes. Scheduler gets the requirements for the new object and it gets the current state of the cluster, including the resource usage data for each worker node in the cluster. The scheduler also takes into account quality of service requirements, data locality, affinity, taints, tolerations, etc. The scheduler is highly configurable and customizable. A scheduler is extremely important and is quite complex in a multi-node Kubernetes cluster But in a single node cluster, the scheduler's job is quite simple. The control managers are control plane components of the master node, which run the controllers to regulate the state of the Kubernetes cluster. In case of a mismatch, corrective action is taken until the cluster's current state matches the desired state. Kube Control Manager runs controllers responsible to act when nodes become unavailable to ensure pod count is as expected, to create endpoints, service accounts, and API access tokens. Cloud Controller Manager runs controllers responsible to interact with the underlying infrastructure of a cloud provider when nodes become unavailable, to manage storage volumes when provided by a cloud service, and to manage load balancing and routing. Last but definitely not the least is etcd, which is a distributed key value data store used to persist the cluster state. New data is written only by appending to etcd. Data is never replaced in the data store. Obsolete data is compacted periodically to minimize the size of the data store. Out of all the control plane components, only the API server is able to communicate with the etcd data store. In Kubernetes, besides storing the cluster state, etcd is also responsible for storing configuration details such as subnets, config maps, secrets, etc. Thank you very much for listening to this episode on the masternode. Watch out for another episode for the worker node. This is Funny Sidela. I'll see you in the next episode.
If you like this episode, please consider following us wherever you hear your podcasts.